as we start the second day of 1.6, I want to just start with a quick little recap just to make sure that as we're going through this chapter, you're comfortable with what we've done so far. So first I want to look at inequality, since the last lesson didn't have inequalities, kind of recap that. So when you're solving your inequalities, this is a compound inequality because you see the word or. When you see the word or, you should think, okay, ors are going to go opposite. I'm going to have a graph that's going opposite ways. I'm going to solve each piece independently, divide by -3. So x is going to switch the inequality because you divided by a negative. And then I'm going to solve the other part by adding 3. Kind of run out of room here. I get x greater than or equal to 10. So that is called your set notation of your answer. I'm going to graph it. So -5 is the smaller one. I'm going to put that first. 10 is over here. My -5 is an open circle. Positive 10 is going to be a closed circle. So I'm going to kind of fill that in. And I'm going to go opposite, less than -5, greater than or equal to 10. Those are what your OR graphs are going to look like. They're going to have that gap in the middle. And then your interval notation, we always start at -infinity, and we're going to go to -5. And we're going to join that or unite that with 10. 10 is going to have a bracket around it because it is included. It is the only time you use a bracket with that closed circle. And then we're going to go to infinity. When you write your OR inequalities in interval notation, it will be made up of 2 intervals. It's the only time that happens. What we did last class is we started working with absolute value inequalities. So with these, nothing to graph here, not multiple notations, but we have to isolate the absolute value. So we're going to add 1 to both sides. So we have 2, 3x minus 5 equals 14, divide by 2. Again, you cannot distribute across an absolute value. You get 7. Now, what I know about this one is this is going to be one of the simpler ones because I only have a variable on the left side. So we're going to break it down. One option is that 3x minus 5 equals positive 7. And one option is that 3x minus 5 equals -7. Add 5 to both sides. You can do that in both pieces if you'd like. So you get 3x equals 12. So x equals 4. And then when I add 5 on this one, I get 3x equals -2. So x equals -2/3. Now, both of these should be valid solutions. We should not have an extraneous because we didn't have variables on both sides. But if you want to check to see if your answers are right, you can grab a calculator. And we're going to type in 2, go to math, number, absolute value. 3 times, I'll check 4 first, 4, minus 5. And then outside the absolute value, -1. And that equals 13. And then I'm going to do a quick check on the other one, 2, absolute value, 3 times, what is it, -2/3, -2 divided by 3. Oh, and there's -5. And then outside the absolute value, -1. And we get 13. So both are valid answers. So that's what we did over the last couple days. So today's lesson is the second half of 1.6, and now we are focused on looking at absolute value and inequalities that are going to be working together. So we've talked about inequalities before. We've even talked about compound inequalities before. If you remember my compound inequalities, I had 2 types, and or. So what's going to happen with these is you are going to be looking at an absolute value that has an inequality sign. So all the ones we did last class were absolute value equations, ones that had equal signs. Now I have absolute value with less than signs and greater than signs, less than or equal to, greater than or equal to. So how we treat them, how we solve them is going to depend on which inequality you have. So I'm going to break this up into 2 videos. I'm going to focus just on the less than ones in this video, and then I'm going to do the greater than ones in the next. So you can kind of see it as 2 different processes. Here's the way I tell students to remember which one's which. And you don't have to memorize anything. You should be writing this down and utilizing your notes so you never have to worry about trying to memorize. But this is a good way to kind of keep it straight in your head. If you have an absolute value with a less than sign, I always think of the words less than sounds like and, less than and. We're going to take our less than sign, we're going to take our absolute value inequality, and we're going to turn it into an and compound inequality. If it has a greater than sign, I think of the word greater and kind of say greater, then we are going to use it as an or. I'm going to save that for the next video. Let's start with the less than. So if you have an absolute value and a less than, your first step for all of these is to make sure you isolate the absolute value. Once it's isolated, which this one is, you're going to take this and you're going to sandwich it. If my absolute value is less than 8, then that means the distance has to be somewhere between positive 8 and negative 8. So I'm going to turn it into a and inequality where I have 3x minus 4 is less than 8. And I'm going to put it between negative 8. So I have this as an and inequality because I've sandwiched it between two values. One value is going to be the positive, one value is going to be the negative. Notice that my absolute value are both pointing towards the negative. They should both be pointing to the smaller number. So that's what I'm saying. My answer is sandwiched somewhere between negative 8 and positive 8. To solve these, whatever I do in the middle, I'm going to do on all three parts. So I'm going to add 4 everywhere. So I get negative 4 is less than 3x is less than 8 plus 4 is 12. And then I'm going to divide everything by 3. So negative 4 thirds is less than x is less than 4. When you finish solving these, your inequality should still be pointing the same direction and should still be pointing to the negative, to the smaller answer. You will not have to check these. What you will have to do though is graph them. So we're going to take our number line and put negative 4 thirds here and 4 here. Both of my circles are open. And then I'm going to connect between them because my and is a sandwich. So what I'm saying is all of my values between negative 4 thirds and 4 would make this inequality true. So you could check, you could put 0 in or 1 in, any number in there and make sure that it makes a true statement. Your interval notation, we're going to use parentheses because we're not including, would be 4 thirds to 4 in parentheses. So that's what a less than with an absolute value will look like. Let me show you a couple more before we end this video. So this one is identical, except for instead of a less than, it has a less than or equal to. That's not going to change much. We still are going to put the 3x minus 4, but now instead of less than, it's less than or equal to, which means when I sandwich it, I'm going to do another less than or equal to negative 8. So you're going to basically duplicate that sign. So now we are sandwiched between negative 8 and positive 8, including those values. The only thing that's going to be different about this is your circles at the end. So when you get to the end, you're going to add 4. I know we just did this one, basically exact same thing except for the sign. Divide by 3. So now my set notation, the only difference is my signs are less than or equal to. What that's going to do on your graph is it's going to close in your circles. Close in my circles. But you're still going to connect. So we still have a less than, which makes it an and, but since it's a less than or equal to, you're going to have closed circles. What it's going to do to your interval is it's going to put it in brackets because both of the endpoints are included. So that again is another example of how we deal with a less than. If it has the equal to with it, all that changes is when I finish, I'm going to have closed circles. I'm going to have brackets around my interval answer. Let me show you one more less than. This one has an extra step at the beginning. I cannot start this one as far as making a sandwich until I get the plus 4 to the other side. I have to isolate first, just like I did with the equations. I had to isolate before I went further. This is again a less than, so I want to think absolute value with less than turns into an and sandwich. So I'm going to sandwich 3x minus 2 is going to be between positive 3 and negative 3. I'm going to add 2 everywhere. So I have negative 1 is less than or equal to 3x is less than or equal to 5. Divide by 3. So negative 1 third is less than or equal to x is less than or equal to 5 thirds. On my number line, I'm going to put my negative 1 third and my positive 5 thirds, and both circles will be filled in here. So I'm going to fill in my circle, fill in my circle. All of my answers are what is between negative 1 third and 5 thirds. Again, if I wanted to test to see if I'm right, I could pick any number in that interval, like 1 would be a really easy one, and I could go back into the original inequality and make sure it made it a true statement. My interval is going to be bracketed negative 1 third, bracketed 5 thirds. So that is how we deal with an absolute value that has a less than inequality or a less than or equal to inequality.